Okay, any questions? So let's start with your questions. Anything you have for me? Yes. Number 15. So number 15 is it, and page, if you could give us the page too. Page 120. 15 on page 120. Very good. So we have 25. 25 minus bracket 2 plus 5y minus 3, open a parenthesis, y plus 2. Now close the bracket and the equal symbol. Negative 3, parentheses, 2y minus 5. And then minus bracket again, open a bracket, 5, y minus 1. And then minus 3y plus 3. And close the bracket. Okay, this is a linear equation. Let me remind you the 3 types of grouping symbols. One that is not here is braces. So that has the third priority. This is the third priority. The second priority is brackets, and the first priority is always parentheses. So we always take care of parentheses and then brackets, and if we have braces, that would be the third step. Now, I also want to mention the absolute value. We discussed last time, we looked at the absolute value function, and we graphed one. So this is the absolute value, which is not a grouping symbol. Not a grouping symbol. These are grouping symbols, but the absolute value is not a grouping symbol. Meaning, so what's the difference? The difference is that for example, in parentheses, I can distribute. In the absolute value, I cannot. In parentheses, I can factor out. In absolute value, I cannot. So the absolute value can never be treated as a grouping symbol. Okay, coming back to our equation. Where is my starting point?
Y plus 2.
So, say it again.
Y plus 2 in parentheses at the top.
So this is the starting point indeed. So what do I need to do? Let me see if I can change a little bit. Is this better? Okay, so yes, this is the first step. I have to distribute negative 3 to these two terms. Also, negative 3 has to be distributed to these two terms. Also, 5 has to be distributed to these two terms. So this is the first step that I have to perform. In other words, eliminate parentheses. And there are no more parentheses after I'm done with this. So can anyone dictate the first step? I have to copy 25. Everything else gets copied. Nothing will be changed. So 25 minus bracket. I have to copy 2 plus 5y. But now what do I write next? Minus 3y minus 6. Close the bracket, and I reach the equal symbol. Perfect. Good. Then the equal symbol. What is the next step? Awesome. And here I cannot change anything. I have to stop, copy the negative sign, and put the bracket. What do I have in parentheses? 5y minus 5 minus 3y plus 3. So this is minus 3y plus 3. Very good. What is the next step? The next step must be combining like terms in brackets. Do not do anything other than combine these, present the information or the expression in the descending order. So I copy 25 minus a bracket, and now I have to perform the operations in brackets and simplify everything I have, but I have to present the answer in descending order. So 2y minus 4 indeed equals. I copy negative 6y plus 15. Again, I reach the minus sign. And now I combine like terms in brackets. What do I get? Two y minus 2. Do we all agree with these steps so far? Yes? Okay. Now, at this point, I'm ready to eliminate brackets. I will distribute negative 1 to these two terms, and I will distribute negative 1 to these two terms. So 25, can anyone dictate?
Minus 2y plus 4.
Perfect. And the right-hand side?
Negative 6y plus 16 minus 2y plus 4.
Very good. Now we're back to what we studied last time, what we looked at last time. Of course, I have to combine like terms, present everything in descending order on both sides. In other words, what I like to say, clean it up, and then proceed. I'm sorry?
Would you move everything to one side?
Very good question. Never for linear equations.
Okay.
That's the answer. That's the recipe for 0 on one side is for quadratic,
Okay.
not for linear. Ready? So negative 2y plus 29 equals negative 8y plus 17. Agreed so far? Now, only now I move terms around. I will be moving the negative 8y to the other side and becomes positive. I will be moving 29 to the other side and it will become negative. So the left-hand side will be 6y and the right-hand side will be negative 12. Do you agree with this? Everyone? So then, final answer, negative 2. Good, very good question. Anything else for me? Anything else for me?
47.
47. Very good, because what I wanted to do before we continue with 47 is go back to the previous problem that I rushed through to finish before ending yesterday, Tuesday. So can anyone give me that problem one more time? I would like to do it one more time, and then we'll do 47.
It's
Yeah, can you just dictate it to me? That's fine.
yeah, it's parentheses.
So any questions on this problem, or can I put it aside? Thank you. Okay.
It was parentheses 4y minus 3.
It was a rational equation.
Yeah, it's this one right here. It was 4 over x minus 2 plus 3 over x minus 5. Wasn't that plus 5? Oh, sorry, it's plus 5. I'm looking at the other one. Sorry. 3 over x plus 5 equals 7 over x plus 5, x minus 2.
No,
No, it's
the
3 over x
denominator
minus
was
5.
x plus 5.
So is it 4 over x minus 2
Yes.
Yeah.
plus
That is
3 over x plus 5
Let me show you.
3 over x plus 5? Equals?
equals 7 over,
Thank you so much.
okay, got it, thank you.
Okay. Perfect. So I would like to redo this problem because I rushed through. Everything that we studied so far is a review of what you have studied in previous classes. And as I mentioned before, if you're comfortable with another method than the one I present in class, please use yours. So if you remember what we said, this is a rational equation, and rational equations are very special. Why? Because they have x in the denominator, and we have to state what it's called restrictions, right? Because I know that this fraction will not exist, will be undefined, if x would be 2. So that's why I have to exclude that possibility from the very beginning. The same thing for this one, and we decided that x cannot be from this. Perfect. And there is no point in writing these two again because x is not 2 and x is not negative 5. So no matter what solutions we get at the end of the day, they cannot be, or the solution or solutions cannot be these for sure. Anything else would be acceptable assuming we did not make a mistake, but these two are not acceptable. Agreed?
Yes.
Perfect. Why? Because they make expressions here disappear, be undefined. Perfect. Then I suggested to you to move this term to the other side and have 0 to the other. So I move this term from one side to the other by simply changing its sign, and the right-hand side is 0. So 4 divided by x minus 2 plus 3 divided by x plus 5 minus 7 over x minus 2 and x plus 5. Questions here? We didn't do anything. We just moved one term from one side, a fraction, a term, it doesn't matter, from one side to the other. Any questions? Now I have a question. What is the next step? What do I need to do now?
Lowest common denominator.
Yes, the least common denominator. So if I forget the equal symbol and 0, I will not be able to solve. If I forget this, I will only come up with an expression, but I will not solve the equation. So be very careful. This must be in there. Good. So what is the least common denominator? So x minus 2 and x plus 5. Remember, the least common denominator has to have all different factors we see here. I only see 2. Now what happens if one of them has power 2? Well, there's a different story. It's a little bit more complicated, and I have to choose the highest power. But all factors, both, have power 1. That's why this has power 1 and this has power 1. It gets more complicated when the power is not 1. So now, remember what I said on Tuesday. I said I took the liberty to multiply this by this, the denominator by this. Well, I have to multiply the top by the same quantity. I took the liberty to multiply this in the denominator by x minus 2, so I have to do the same thing to the top. And there is nothing I can do to the other one, the third one, because they both have the same denominator. If you want to write something, you can, but it's 1 and not 0 or something else. So now we know what we have at the top. What do we have?
4x.
We have 4x and we have 20 plus
3x
3x minus 6 minus 7. Do you all agree with this step? Everyone, any questions? Everything okay? Perfect. So now I will combine like terms. And I have 7x, and this is 20 minus 13. So this is plus 7 divided by x minus 2 times x plus 5 equals, and I said, with your agreement, I will write 0 as 0 over 1, only to make a point. It's the same thing. 0 or 0 over 1 is the same thing. But here's the point I'm making, that this now is a very important let me write it again. It's a proportion. It's very important to remember this because a proportion has a very special property. Only in a proportion I can cross multiply. So let me show you a proportion. So A divided by B equals C divided by D. What is a proportion? One fraction on one side, the equal symbol, and one fraction on the other. Only in a proportion I can write AD equals BC. So now if you're wondering, wait a minute, what happened to B? Nothing. Where did the denominators go? Nowhere. They're right here. A times D is this side, and B times C is this side. So this is still a rational equation, but it's the simplest possible rational equation in which I can cross multiply. You understand we could have not done this from the beginning because we have 3 fractions. So now this times this, this times this is 7x plus 7 equals, according to the proportion property, cross multiplication rule, equals this times this. But how much is this times 0? 0. Now this is linear. It's not quadratic. So I have to move 7 to the other side. And I divide by 7, and that's how I get the -1. My first thought must be to go back to the list of restrictions. If this number, -1, is in the list of restrictions, I'll say no way. If it's not on the list of restrictions, I will say yes. Again, assuming that I did not make a mistake down the road. So this is the method I recommend. If you know a different one, if you like a different one, I'm fine. If you'd like to multiply both sides, be careful how you multiply. That's a different method. I accepted, everything is fine. I just would like you to see this method that I like to present. And if you still say, I think it's better for me to stick with my method, I'm fine. Any questions? Okay, do we still need to do 47?
Please.
Okay, very good. So let's look at 47. 47 on page 120. 47. I see. 2 over x plus 1 minus 1 over x minus 1 equals 2x over x squared minus 1. Perfect. Did I copy it incorrectly?
No, you did. No, you did.
Always check. I have a habit of having hard for
I
one.
was like confused because
I
I was
have-
like next square.
Sometimes I copy, and I should have told you from the very beginning. Sometimes I copy half of a problem from 47 and the other half of 48. So please keep an eye on that. In my calculus class last semester, I tasked someone to double check and make sure that I copy the correct problem. And at some point in time, he said, "Can you assign somebody else? I'm fed up with this." He was joking. He was in my pre-calculus class, and he knew that. Okay, good. So it is a rational equation. What do I do? First,
Take the right side move to the left.
yes. However, I would like to start with restrictions. Obviously, x cannot be very good, and x cannot be very good. And I also need to factor this. On the first day of classes, we refreshed our memory on this special product and 2 other special products.
That's the difference of perfect squares.
Awesome. Oh, absolutely awesome. I don't know why. Combining words right now. I'm still laughing. Okay, it's awesome. It's the difference of squares. Perfect. So, I wanted to say 2 things at the same time. Okay. So, indeed, what is it? Awesome. Good. There is no point in reassessing or writing these restrictions because they're already here. Good. Perfect. Next. This is my page 3. Yes, you already told me to move. I have 2 over x plus 1 minus 1 over x minus 1 minus 2x over x plus 1, x minus 1. I need the denominator factored. And now what is left on the other side? Right. If I miss that, I'm messing up the entire problem. So the next step would be, if you're using a different method, that's fine. But right now, I'm just going to write the least common denominator as being the 2 factors that we see in the denominator. I will find the adjustments, the adjustment for the top of each fraction. What is the adjustment for the first one? Ooh. Indeed, x minus 1 for the second one. And for the last one, it should be anything or just 1. Can anyone dictate the top?
Minus 1.
Good.
Minus 2x.
Perfect. Do we all agree with all these steps? Any questions for me? Any questions? Yes, please.
I guess I do kind of have a question.
Yes.
So I did plus 1 before, so do you have to distribute the negative that's in front of the first fraction?
Mandatory. The negative in front of a fraction acts like the negative in front of a grouping symbol.
Okay.
And it always goes to the top.
Okay.
Yes. Good. So 2x minus 2 minus x minus 1 minus 2x. Next step. Right. So I have 2x minus 2x will go away. And I have a negative x and I have a negative 3 over x plus 1, x minus 1. And now I'm doing that proportion thing. Which gives us
Negative x minus 3 equals 0.
very good. Do we all agree with negative x minus 3 equals 0? So now if you want, you can move x to the left and to the right hand side if you, it doesn't matter. Or just say this or this. So I have to move -3 to the other side, it becomes positive, and I have to divide both sides by -1. That's how I get x equals -3. What is my first thought before I say check?
Does it match with the?
Yes.
Or it cannot be.
Is -3 on the list of restrictions? The answer is no. So I'm assuming that I did not make any mistakes, so this should be the correct answer. Very good. So this really helped me because I wanted to go back and redo it, a rational equation anyway. Other questions for me before we move on?
41.
Yes, from?
One page 120.
Okay, 41. So let's take a look. What was the problem with 41?
8x over x plus 1 equals 4 minus 8 over x plus 1.
Good. So what was the problem here? What do you think we needed to look at this?
So no matter how it works out, the x always equals what it's not supposed to be. That was my
We'll see in a moment. So I look at this equation and I see something that I haven't seen in the other two. I see the same denominator. I don't care about the numerator. I see the same denominator. So I'm going to bring this here. And I have 8 over x plus 1 plus 8 over x plus 1. What do I get?
That's 8x.
Oh, is it?
Yeah, 8x.
Ah, a different story. Okay, I'm still going to do the same thing. So then I have 8x plus 8 divided by x plus 1. Do you agree so far? Because these two have the same denominator, I will move positive, so it's positive 8 over x plus 1. What is the restriction that I have to state from the very beginning?
X not be -1.
Very good. So far, so good? Is it clear how we got that?
Yeah.
So we moved -8 over x plus 1, we moved it to the other side, became positive. But since they have the same denominator, I can write 8x plus 8 over x plus 1 because they have the same denominator. So this is what I'm going to do next. Why? Because this is already a proportion. So let's cross multiply. 8x plus 8 equals 1 times 1 is 8x plus 8. And x plus 1 times 4 is 4 times x plus 1. Is this okay?
Yeah, I just went ahead and distributed it before. Is that okay? 4x plus 4 on the other side?
Yeah, you can. I just wanted to show how I got that, and then that will be my next step. Yes, of course. You don't have to present each and every step that I present here. Okay, so then I have 8x plus 8 equals 4x plus 4. Linear equation. I will move terms around. And what do I get on the left-hand side?
4x
I get 4x equals,
-4.
good, which means x equals. So what will I say? We cannot say for an equation, about an equation that it's undefined. We can say,
No solution.
very good. We say undefined for a fraction when its denominator is 0. Very good examples. Anything else for me? You can always stop me if you have other questions or you remember something. I would like to move on to 1.5, quadratic equations. So I can say right now that 1.1 and 1.2 are done. One more time, once we get into the habit, I promise you that if you follow my lead, you are going to be very happy, and I will be very happy. So number one, redo the problems we just did last time and today. Look at the problems that are selected by my department and check the answer in the back. Read the examples in the book. There are tons of examples. Problem solved in the sections 1.1 and 1.2. And only then finish up your homework. It's okay if you don't have everything done between now and Tuesday. But if you say, oh, I'm going to do it on Tuesday, it's not going to happen. Number two, you're not going to be able to participate in discussions and you will feel left out or you will feel that you are already behind. And I don't want this to happen to anyone. I don't want to leave anyone behind. But at the same time, as I said, I have to finish number three. So I will be here since my colleague moved her class. I will be here early. If you want to come in early and ask questions, I'll be more than happy to help you. I also have office hours after your class. If you want to stay here in the room with me, I will be more than happy to help you. Okay? Yes? Okay. So section 1.5 is a complete review like the previous ones, but I don't want to consider that. I want to look at everything with you. So 1.5, quadratic equations. Okay. Quadratic equations are of the form ax squared plus bx plus c equals 0. So this is a quadratic equation, the standard form of a quadratic equation. We do have four methods of solving quadratic equations. And you could say, really, do I really need to know all four? They have different applications. So if you want to be able to solve problems fast, if you want to be able to easier recognize, or if you want which method to apply where, we need to know all four, right? There is one particular one that I would say, I have to be honest, it's not used for solving quadratic equations. I'm going to list them in a moment. That particular method is used for something else, but it's applicable here as well. For something else that will come into play in this class later on. So here are the four methods. Number one, factoring. Now you can say, do I really need factoring? Factoring is a very good skill to have. Very good skill to have. But I would say also this. If it takes you more than 20, 30 seconds to factor, forget it. Use a different method. Unless you're specifically told you have to factor. Okay? So factoring is not applicable in all cases. Not all polynomials are factorable. We wish they were, but they're not. So factoring has limited application, but it's a good skill to have. Again, if it takes longer than 30 seconds, forget it. I'll show you other methods, and I'm sure you do know them. Number two, taking square roots. Taking square roots from both sides of an equation. This is extremely useful. Extremely useful, but as long as the equation is set up not like that, but like this. So let's say this is an example. X plus 1 squared equals 4. So I will take square roots from both sides here, and I'll explain how to do it. I will not use factoring, because I can't. I will not try the other two, because the third one is not applicable here. And I will not use the fourth one. A specific type of equation for taking square roots. So this is very useful. And this is very useful. Number three is not useful here. Completing the square. Completing the square is not useful here. But it's a method that is applicable. However, it alone cannot solve a quadratic equation. So see, complete the square means change that expression into something like this and have a number on the other side. But once I get it I complete the square and I get into this form, how do I complete? How do I solve? I have to go back to taking square roots. So complete the square alone will not solve the equation. After I complete the square, I have to use method number two. So this is not recommended, but it's a method that we need to learn for something else later on. And the last one is quadratic formula. So this will always work because I will always be able to complete the square. This will always work because this works. This will always work. The only one that will not always work is factoring, because not all polynomials are factorable. Okay, Now, I did give you a handout. I saved two to show you, but now I have two new students, so I gave them up. So I don't have I can go back to the handouts. Okay, so it's this document on factoring. It has 2 pages, this document. And the third page is, here is the third page. So the document has 3 pages, and I would like us to take a look. And I would like you to let me know which type of factoring you have difficulties with. And yes, I know you're going to say all of them, but I hope you're not going to say all of them. So number 1, factoring. There is also a homework on factoring in my math lab. So remember that. Yes. Can I borrow your document for a moment? Okay. So this document is created by me. And this is how I present factoring in any class that factoring is presented from scratch. Now here, this is a summary of everything that you will ever encounter in factoring. So I recommend always bring these documents with you. Staple them, clip them to your book maybe or to your notebook, okay? So always bring these documents with you. So what am I saying here is the strategy for any type of polynomial. If I'm given a binomial, I have a certain strategy, certain scheme, certain order of steps. If I am given a trinomial, then I have a different method. If I'm given to factor a polynomial, it's a different method. So the first thing I have to do is identify the type of polynomial I'm given. So if I say binomial, then I go this way. If I say trinomial, then I go this way. And if I say polynomial, then I go this way. Okay? So, what would you like to start with? Of course, the most difficult are trinomials. Yes, I agree. The most difficult are trinomials. But I would like you to understand that all these steps have to always be in this order. First step, I ask myself what it is. Second step, I ask myself if it's in descending order. Third step, I'm asking myself if there is a greatest common factor. And the last step, if there is a negative leading coefficient. And only then I channel myself based on binomial, trinomial, and polynomial. So the first 4 questions are always the same. Okay, so please choose any trinomial that you would like to see. I wish I could find the time to go over everything, but there is no way we can. So we can choose a couple from binomials, a couple from trinomials, and a couple from polynomials. If you want, I can choose. Yes, if you want, or any other. That's fine too. So, so you want to start with binomials, or you want to go directly to trinomials? It's fine. Okay, so for example, for the special product, so there are 4 special products. If you look at the strategy, there are 4 special products for binomials. The first one we reviewed last Tuesday. What is this first one equal to? So let's write it here. What is it?
A to the second minus B.
Say it again.
A to the second minus B.
Yes, this one, the first one. What does it equal to? Going backwards
A
now.
squared plus 2ab plus b squared.
Awesome, but this is trinomial. We're talking about binomials, right? Right? So I'm talking about a squared minus b squared. Let's go back to the handout from from Tuesday. What did we write for this?
A squared minus 2ab plus b squared.
That's a trinomial.
Oh, that's what I wrote down.
It's a trinomial. You did not write this for a squared minus b squared. You wrote for a minus b everything squared. Right? wanna make a mistake.
A plus B,
So
A
this
minus
is a plus b squared, which is this. So it's the binomial squared, but that's not a binomial squared. That one is this one. It's a squared minus b squared, which is this. Right?
Right.
Everything you wrote is correct. I just wanna make sure. Okay, so then, can anyone give us the factor form of this? And let's write it.
Quality A plus B times quality A minus.
Right. So the first one, a squared minus b squared, I don't need parentheses, is a plus b times a minus b. So that's the first one. Oh, no one can see what I wrote.
No.
I wrote exactly what we did last time. I didn't invent anything. This is not new. Right? So what will you write for the second one? A squared plus b squared on the document. But can a squared minus b squared and a squared plus b squared be the same?
A plus B, A plus B.
But that is a trinomial. A plus b, everything squared is, yeah. So let's write not factorable. A squared plus b squared is not factorable using integers. A squared plus b squared, not factorable. To be exact and accurate, I should write using integers. Okay, what about the last two? Can anyone name the last two? So this was the difference of squares. What is this again? Sum. If this is the difference of squares, what could, sum of squares, correct. So now let's look at the last two. A cubed minus b cubed. And a cubed plus b cubed. What do you think these are named? What is the name of these two?
Difference in sum with cube.
Of course. Of course. Does anyone remember the special product?
Oh, that's.
Okay, that's okay. So this is a minus b, so it's a binomial times a trinomial.
That would be A squared
Perfect.
plus AB
Awesome.
plus B squared.
Awesome. Great. And what if I have a sum like this one? What will happen? This will have the sum right here, and this will have the minus. The last one is always the sum. Very good. So the difference of cubes factors into a binomial times a trinomial. A minus b, if this is negative, and positive in here. So minus, minus, plus, or plus, plus, that's it. So if I factor the difference, the binomial has the difference. If I factor the sum, the binomial has the sum. And in the middle here, it has to be the opposite. Bless you. Good. So now please choose anything you want to see from those examples from binomials. From these. So there are 2, 4, 6 examples. We should choose one with a difference of squares and one with a sum or difference of cubes.
Can we do E?
Yes, let's do E. Perfect. Perfect. Awesome. So in E we had 1 over 27 minus x cubed,
1 over 125.
125. Minus x cubed? Okay, very good.
This
Plus.
plus
Plus x cubed.
Very good. Okay. So my first question to myself is, what type of polynomial is this?
is the sum of two cubes.
So the answer is a binomial, because remember there are 3 different strategies. One for binomials, yes,
Is that 12?
125.
125?
Do you have the handout?
Yes.
E is 125. She got it right.
When you said E, I thought
You have it right.
we were looking at 1 over 27 minus x cubed,
Where is that?
right here.
Yeah.
1 over
that's
27, that's what I thought.
That's not.
That's
That's
not.
not
That's not on ours.
It's not on ours.
Oh, okay. Good. So let's do both. So So 1 over 27, 1 over 25 plus x cubed, and then 1 over 27 minus x cubed. We're going to do both. How is that? Is that okay? Very good. So the first question I have to myself is, what is it? And the answer is a binomial. Second question I have for myself is this in descending order? No, I have to arrange it in descending order. So I have to write x cubed plus 1 over 25. So far, so good? Perfect. Good. So now I go through the strategy. It's in descending order. Greatest common factor. Do these two terms have a common factor? No. Very good. Does the leading coefficient, is the leading coefficient negative? No. So now I'm down to the special products. There are two special products with the sum. The sum of squares or the sum of cubes. So what do you think, which special product is applicable here? Sum of cubes. Once you say the sum of cubes, then I have to get ready a binomial and a trinomial. Can anyone tell us what cubed is x cubed? X cubed. So the question was, what cubed is x cubed? And the answer is x. Now, what cubed is 1 over 125? Very good. So I discovered already the binomial. Let's write the sequence of signs first before I write anything. I'm factoring the sum of cubes. What is the sign inside the binomial?
Plus.
And what will be the sign in the middle of the trinomial? Negative. Perfect. So plus and negative, and the last term is positive. Good. So now please give me these two terms. Exactly what we just determined. Awesome. X plus 1/5. Good. Now, all I have to do is remember the pattern. Square the first, multiply the two, and square the last. So please, let's square the first.
X squared.
Please multiply these two.
1/5 x.
1/5 x. And plus, please square the second term. 1 over 1 over 25.
Oh, is it? That's where it's at.
Very good. Well done. Let's also look at the other one. 1 over 27 minus x cubed. Any questions here?
Wait, so is that the answer?
That's it. That's the factored form. And here's a question for you. What if I have doubts about my work? What if I say, oh, I'm not really sure, maybe this is not right? What do I do? Not plug it back in, but multiply. So x times this, x times this, x times this. This times x squared, 1/5 times negative 1/5 x, and this times this. There are 6 terms, right? 3 and 3 more. So how many have to go away? 4. Exactly. Because I started with 2 terms. 4 of those have to go away. Would you like to see that, or you will do that on your own to check? Are we comfortable with the formula, with the special product? Yes or no? Yes?
You could show it. I'd like to see it.
Multiplying?
Yeah.
Okay, so x times x squared is x cubed. X times negative 1/5 x is minus 1/5 x squared. X times 1 over 25 is 1 over 25x. 1/5 times x squared, 1/5 x squared. 1/5 times negative 1/5 x is minus 125x. And this times this is 1 over 125. This go away. This go away. And I get back x cubed plus 125. 1 over 125. Very good. So now let's work on the other one. 1 over 27 minus x cubed. First question to myself is, what type of polynomial is it? What type is it? It's a binomial. Is it in descending order? So remember, again, I accept any method, but if I could borrow, yes. These are the top steps. If you omit one of these steps, you may end up not being able to factor. So that's why I repeat myself like a broken record. So First step is what type of polynomial is it? Binomial. Second step, is it in descending order? The answer is no. So minus x cubed plus 1 over 27. Then I see that it has a negative leading coefficient. I have to pull out negative 1. Mandatory. What is left in parentheses?
X cubed minus 1.7.
Very good. Very good. And now I'm asking myself which special product is applicable if one, I should try if one is applicable. Since I have x cubed, I cannot think of the difference of squares. It has to be the difference of cubes. So once I say the difference of cubes, then I will have to get ready what and what. Very good. Sequence of signs. If the binomial that I factor, the trinomial that I have to factor, I'm sorry, the difference of cubes that I factor has minus because it's a difference, I have to have minus in the middle of the binomial, and I have to have plus in the trinomial. So, what do I cube to get x?
Yes.
What do I cube to get 1 over 27?
Whatever.
3.
1 over 3. Very good. And now the pattern for the trinomial. Very good. 1/3 times x. Good. And the last one? That's it. Do we need to see anything else from binomials?
So we just leave the negative on the outside. Just
Yes, that's an additional factor of -1. Very good question. Yes. That's an additional. Yes, please.
Can't the trinomials be factored in more? Why don't we do that?
Very good question. No. If this trinomial comes from a difference or sum of cubes degree 3, no. If it comes from degree 6, it's possible. But no, this does not have, it's not factorable, doesn't even have real solutions. Very good question. Thank you. Next question, please. Anything else from binomials? Anything else from binomials? You would like to pick another? Okay, I want to pick one. So let's say x to the 4th minus 81. My first question is, what type of polynomial is it? And the answer is binomial. Is it in descending order?
Yeah.
Yes. Negative leading coefficient?
No.
Greatest common factor? No. It's a difference. I have two options for differences. The difference of squares and the difference of cubes. Which one is it? I have to admit, there are certain situations in which both of them are applicable, but not here. So which one? The difference of squares. Very good. If you say the difference of squares, then you will give me two binomials. What do I square to get x to the 4th? Awesome. What do I square to get 81? Good. So what should I write? Very good. Now we do have to continue analyzing these two options, these two factors. Is this further factorable?
No.
Why? You wrote it. You wrote it a minute ago. Because this is the exactly. And the sum of two squares is not factorable. You have it in your notes 5 minutes ago. What about this? Is this further factorable?
Yes.
Yes, that is further factorable using the same procedure. So a binomial times a binomial. I'm using the same method, the same special product. One more time. What do we get?
Is it x plus 3, x minus 3?
That's it.
But I'm confused. Why couldn't you do that with the second one?
We wrote it. X squared, a squared plus b squared is the sum of squares, which is not factorable using integers. Sum of squares is not factorable. Okay, finally, let's move on to trinomials. Please choose any problem for trinomials. So these were binomials, now trinomials. I hope we move on from factoring and this is done for good. Trinomials.